Good morning everybody and welcome to today's worked exam answer video. Today I'm taking a look at a question which is asking us to explain, using particle collision theory, how increasing the temperature affects the rate of a reaction. Now this specific question comes from an Edexcel GCSE double award paper. But in terms of how important this will also come up in AQA GCSE exam papers and probably other specifications that I am less familiar with. So I think when I've tutored OCR previously at GCSE, it comes up on there as well. But also understanding this is key to understanding the kinetics topic in the AQA A level. And also being able to take that a step further in the rate equations topic in year 13. So it's kind of a fundamental thing to be able to explain and to use the right sort of terminology and to understand what that means. So whilst this is focused specifically for GCSE students, because it is a GCSE question, if you are studying for chemistry A level, you might just want to check that you're happy with everything that I'm discussing in this video. Now, one of the things that I'm going to point out is how many lines they give you to answer this question. So I've snipped this straight from an exam paper and then I put it into a blank PowerPoint slide to be able to print it off. That's how many lines we've got. Now, I don't know how many lines I'm going to fill till I've filled them, but I imagine I'm going to be somewhere up here. So please don't worry if you do not fill all of the lines that they provide. Often the better answers don't fill all of the lines because they're being concise, to the point. You know, they're not waffling and saying everything that they possibly know about the topic. They are just answering the question using the keywords in a concise manner, and A, that's going to save time, but B, you are far less likely to then contradict yourself, say things that are incorrect and thus lose marks. So please do not worry about filling all of the lines you are provided with for an answer. I used to think when I was doing my GCSEs and my A levels that a better answer was a longer answer. Obviously, I've since learned that that is not true. So what we're being asked to do here, as I've already said, is explain. So we've got to say why, using particle collision theory. So using this idea that particles will collide with each other for a reaction to occur, but they need to collide with each other successfully. And I'll touch on what that means. And we're thinking about the effect of increasing the temperature on the rate of a reaction, so how fast a reaction will be. Now, even though it's an explain question, so we've got to say why changing the temperature affects the rate, we need to also say how increasing the temperature affects the rate. We need to describe the relationship and then go on to explain it, because it hasn't said explain how an increased temperature increases the rate of a reaction. So by being more vague like they have been, we're going to get 1 mark here for describing what happens to the rate of reaction when we increase the temperature. Then we're going to get the rest of our marks for explaining why that is the case. So in terms of the relationship, anytime we increase the temperature of a solution, gases, bit hard to do for solids, but anytime we're increasing the temperature of our reaction mixture, we will get a faster rate of reaction. So that is the first thing that I'm going to describe. So increasing the temperature increases the rate of a reaction. 1 mark for describing that relationship. Now we need to think about why. So from fairly low down secondary school, hopefully you would have learned that when we increase the temperature of a liquid, solution, a gas, we're giving the particles more energy, and that's kind of fundamental. knowledge again. So if we increase the temperature, we give the particles more energy. If the particles have more energy, they are going to move around more quickly. And if we're thinking about how that relates to collision theory, if your particles have more energy and are moving around more, then there will be more collisions. They're going to collide with each other more frequently if they are moving around with more energy. That is true, of course, because I've just explained that to you on the video, and I'm not going to tell you lies, but that is not, I guess, the most fundamental argument when we're thinking about temperature. It's definitely something that I'm going to write down, because the first part of the explanation needs to be that the particles have more energy. So when the particles have more energy, we then need to take it a step further and think about how that affects not just the number of collisions overall, but the number of those successful collisions. But I'm going to write that down as my starting point for my explanation. So I'm going to say increasing the temperature gives the particles more energy. And as I've said, yes, that means that there will be more collisions overall, but temperature is by far and away the best variable to change if you want to increase the rate of the reaction, because not only do you increase the number of collisions overall and thus end up with more successful collisions, changing the temperature and increasing the temperature changes the proportion of collisions that are successful. So it's really important that we know and appreciate that the majority of collisions between particles are not successful. The particles will collide, but they'll just bounce off each other and nothing will happen. And that's because when those particles collide, they have to have a certain amount of energy, and that minimum amount of energy that they need for a collision to be successful is called the activation energy. Lots of the particles will collide with energy that is lower than the activation energy, so the particles will just bounce off each other, carry on moving around, bounce into other particles, etc. If the particles collide with that sufficient energy, that minimum energy, the activation energy, that will then enable the bonds in the reactant particles to be broken, and then those atoms can be rearranged and the new products can be made. And that's what we mean by a successful collision. A successful collision occurs between particles that have that minimum energy, which then enables those bonds to be broken so that new products can be made. If we are increasing the temperature, then all of the particles are going to have more energy, and that means that more of them are going to have that minimum energy. So here I like to think about sort of statistics a little bit, because it can be quite useful. So I'm just going to make a few notes of the numbers I'm going to be talking about. So let's say at whatever temperature we use initially, there are 10 collisions per second. Probably going to be more than that, but I'm trying to keep the numbers nice. So we have 10 collisions initially, and out of those 10 collisions per second at the original temperature, it might be that 2 out of 10 are successful. So 8 of the collisions, nothing will happen, particles will collide and bounce off each other, but for 2 of them, you will have a successful collision, reactant bonds will break, new products can be made. When we increase the temperature, so let's just put again some random temperatures to this, let's say that that's at 20 degrees, completely making these numbers up by the way, just to show a point. If we were then to increase the temperature to 50 degrees, not only would we increase the total number of collisions per second, because the particles have more energy, they're moving around faster, they are going to collide more often each second. So let's say there are now 20 collisions per second. If we were just increasing the overall number of collisions, then this ratio of 2 in 10 would stay the same and it would become 4 in 20. However, if you're increasing the temperature to 50 degrees, more particles will have that minimum energy, so the ratio of 2 in 10 also changes. So at 50 degrees, it might be that that ratio turns into 5 out of the 10 collisions will be successful. So if we then have 20 collisions per second, and we're now going with a 5 in 10 ratio, that means that 10 out of every 20 collisions will be successful. So rather than only a fifth of the collisions being successful, half of the collisions are now successful. And that's why temperature is such a good variable to change when you're wanting to increase the rate of reaction, because changing the temperature is the only time you are changing the energy that the particles have. So if you're changing the concentration, there are more particles, but you're not changing their energy. If you're changing the pressure, you're either adding more particles or reducing the volume. There will be more collisions, but you're not changing the energy of the particles. Temperature is the only variable where you are changing the energy of the particles, and not only do you get overall more collisions, but you get a greater proportion of successful collisions as well. So hopefully that's helped to illustrate my point, and now I'm going to go on to finish my answer. So increasing the temperature gives the particles more energy, and therefore more particles will have energy that is greater than or equal to the activation energy, that minimum energy that they need to have to collide successfully. Now I've written that out in a full sentence, but what you could also say there is that therefore more particles will have energy, and use E for energy, that is greater than or equal to the activation energy, which is an E with a little subscript A. That's obviously much quicker. I wanted to write it out in full before I did that so you could see what I was referring to. So just let me reread that again. Increasing the temperature gives the particles more energy, and therefore more particles will have energy that is greater than or equal to the activation energy, and then linking that back to collision theory, meaning there will be more successful collisions per second, or there will be a greater frequency of successful collisions. And it doesn't matter which you say, it probably comes down to the preference of your teacher. I've always taught it as more successful collisions per second, and that's kind of been something I've called the magic rate sentence, because even if you forget exactly why there are more successful collisions per second, that is the fundamental goal of changing temperature or concentration or pressure, to increase the rate of a reaction to give us more successful collisions per second. However, it means the same thing to say a greater frequency of successful collisions, because we're still thinking about the number in a specific time period. So either of those is absolutely fine for that final mark. And that would be it for 4 marks. So notice how much of this paper I haven't written on and the small amount of space that I have required to get my 4 marks. So first, increasing the temperature increases the rate of a reaction. Second, because the particles get more energy when we increase the temperature. 3rd mark, therefore more particles will have energy greater than or equal to the activation energy. 4th mark, either more successful collisions per second or therefore a greater frequency of successful collisions. 4 marks, excellent. If you are studying the A level, this links in nicely with our Maxwell-Boltzmann distributions, where we can see, based on the shape of the curve and where the activation energy will be, how few particles or molecules have energy greater than or equal to the activation energy, and how when we then increase the temperature and the shape of the curve changes, we shift more particles or more molecules to the other side of the activation energy. So that's where the connection lies. In terms of in year 13, looking at rate equations, you will learn about the Arrhenius equation, which is an equation that allows us to put a more quantitative measure between the relationship of activation energy and temperature, as well as thinking about the rate constant, which tells us something about the rate of the reaction. So that's how it then continues to link in to our year 13 work. But this specific question from a GCSE paper, those would be the 4 marking points that you would need. Hopefully, explaining that as I've done helps you to see the importance of changing temperature, the value of increasing the temperature, and why we need to give a little bit more information than we do for other variables like concentration, pressure, or surface area, because of the change to the energy of the particles here. Any questions, as always, guys, please leave me a comment on the video, or please send me an email to missgtutoringandresources@outlook.com. Thank you so much for watching. I really hope you found it useful.